Hello everyone. In our previous lesson, I have shown you how to solve this particular problem directly from the polar equation. So in this tutorial, we are going to convert the polar equation into rectangular equation and still solve the same problem. The question reads, find the equation of the tangent line to the curve r equal to 3 divided by 1 minus sine theta at a point where theta is equal to pi. Let's get started. I would like to find the value of r at a point where theta is equal to pi. Just look at it. Sine of pi is 0. So we have 1 minus 0, which is 1, and 3 divided by 1 is still 3. So you can see that, let me start with r. r is equal to 3 when theta is equal to pi. Next, remember that y is equal to r sine theta. That's the conversion. So if you have this, you can replace it with y. And x is equal to what? R cos theta. Because we are looking for a point. Remember, our line, let me write the equation of the line, which is going to be y minus y1 equal to m, which is the slope, then what? X minus x1. Before we come to this, I would like to find the value of y and x so that we can plug them directly here. So we know that y can now be equal to r, which is 3. And what is sine of pi? We have sine of pi. Sine of pi is 0. 0 times 3 is equal to 0. Then for x, it is equal to r, which is 3, cosine of pi. And cosine of pi, we know it is equal to negative 1. So the moment you multiply negative 1 by 3, you're going to have x to be equal to negative 3. So the point where the tangent is going to lie on the curve will be at a point where x, y equals negative 3, 0. And this is the point we're going to plug in here. We are done with this one. Then let us go to the main equation, which is r equal to 3 divided by 1 minus sine theta. I would like to convert this equation into rectangular equation. So let us cross multiply. You take this, you multiply by r, you set it to be equal to 3. R times 1 is r minus r sine theta. This is equal to 3. What is r? One thing you should remember about r is r squared is equal to x squared plus y squared. Therefore, r, remember, it is a length, so it should be positive, will be the square root of x squared plus y squared. So we can replace r with the square root of x squared plus y squared. Minus r sine theta, remember it is equal to y, and this is equal to 3. Let us take negative y to the other side. We have the square root of x squared plus y squared to the left, and this is equal to 3 plus y. Now I would like to square both sides. Square this and square this. The power of 2 will cancel the square root. You have x squared plus y squared to the left, and this is equal to the expansion of 3 plus y to the power of 2 will be the first term squared, which is 9, the second term squared, which is y squared, then 2 times the first term, which is 6, times the second term, which is 6y. From left to right, if you subtract y squared, they will go. Now let us make y the subject. You can see that 6y will be equal to x squared minus 9. Divide both sides by 6. You have y to be equal to x squared minus 9 divided by 6. This is our equation in rectangular form. But we are almost done because we have a point, 0 and negative 3, right? But we still need this m. And what is this m? M is the slope, which is dy over dx at that point. So let us differentiate this function. Dy over dx will be equal to, since this is constant, just differentiate the top. The top will be 2x minus 0 because derivative of constant is 0. But this denominator will always stay. And if you simplify this, this will be x over 3, right? So therefore, this is equal to x over 3. But what is the value of x at that point? At that point, x is what? Negative 3. So let us bring it back here. So at x equal to negative 3, we have our dy over dx to be negative 3 divided by 3. And this is equal to what? Negative 1. Therefore, dy over dx is equal to negative 1. So now let me bring the whole equation and substitute everything directly. Remember, it is y minus y1 equal to mx minus x1. Y is there, minus y1 is 0, and the slope is negative 1. You can see that here. Then we have x minus 3. Remember, the point is what? Minus 3 comma 0. This is why we have 0 here and negative 3 here. Let's simplify. This is y equal to negative 1 times x plus 3. If you expand, you have y equal to minus x minus 3. And yay, this is the equation of the tangent line to the curve at a point where x is negative 3 and y is 0. But since our original equation is in polar coordinates, we can simply transform back this equation into polar coordinates. All right, let's do that. Remember, y is equal to r sine theta. This is equal to minus x is r cos theta. And we still have minus 3. Bring this one to the left. We have r sine theta plus r cos theta equal to minus 3. Factor out r. You have sine theta plus cos theta and everything equal to minus 3. Divide both sides by sine theta plus cos theta and you are done. Sine theta plus cos theta. This is the equation of the tangent line to the curve at a point where theta is equal to pi. In our previous lesson, I solved it directly without conversion. Thank you for watching. Do share to your learning colleagues. Bye-bye.